As I was saying, this is still growth, but in the negative direction. All right, so in general, here's what you need to be looking at. Exponential growth will start at the x-axis or the asymptote, right? If here's the asymptote, it will start at the asymptote and then eventually move vertically away from the asymptote, either in the positive or in the negative direction. That's growth. Exponential decay, if this is the asymptote, will start away and then get closer to the asymptote. It'll start from far away and then get closer to the asymptote. So both of those are decay. All right, let's talk about E, the natural base. So first of all, where does E come from? Well, in math, it turns out, and in science, in physics, and so on, this term, 1 plus 1 over x to the x, it shows up all the time, like it's everywhere. And then usually what we need to do is we need to take a limit of that function as x approaches infinity. So the way that works is when you graph 1 plus 1 over x to the x, it kind of looks like this. It starts to increase, and then it levels off. And so where it levels off, right, that limit as x approaches infinity, that's this funny value, 2.71828, blah, blah, blah. And because this was discovered by a mathematician named Euler, this received the value of E after Euler. All right, so that's what E is. That's where it comes from. We'll talk more about this tomorrow or next time. All right, so E then is just a constant, right? So if I have f of x is equal to 2 to the x, or if I have f of x is equal to 3 to the x, what's to stop me from having f of x is equal to e to the x? Because E is just a number just like any other, 2.71828. Okay? All right, so let's graph e to the x. The asymptote, again, is y equals 0. The y-intercept, f of 0, is e to the 0, so 1 again. Okay, e to the x is growth, so I pick these values again. So I have e to the negative 1, 0, 1, 2, and that'll be 0.4. 1, 2.7, 7.4. All right, and let's graph that. I got 0.1, 1, 2.7, 7.4. All right, so nothing different. Again, nothing different here. They all follow the same patterns as before. All right. Now take a look at this one. I have e to the 2x plus 3. This plus 3 is a vertical shift. It moves the graph up 3 units. So if the graph moves up, so does the asymptote, right? So now the horizontal asymptote is y equals that value of 3. So if that was e to the x minus 4, asymptote would be y equals negative 4. Y-intercept is 4. And then to graph, I do the same thing, right? I'm going to pick these points again. So I have e to the negative 2 plus 3, e to the 0 plus 3. E to the 1 plus 3 is 10.4. And look, if my grid is just going until 10, I'm good to stop there. I'm sorry, this would have been e to the 2 plus 3, 10.4. And this will be e to the 4 plus 3. That will give us too big of a number, and I don't want you to be dealing with too large of a number. 3 points for me is enough for you to graph, so we're just going to get satisfied with this. So I say y equals 3. y equals 3 is the asymptote. So I have at -1, y is 3.1, then 4, then 10.4. All right, I'm going to cheat here a little bit. Okay, technically we should not be going off the grid. We should just be renumbering them. And that's how that looks. Here, everything is going to follow the same pattern. The domain is all real numbers. Now the range is y is greater than wherever the y value for the asymptote is, which in this case is 3. All right. And then end behavior, as x approaches -infinity, the limit is 3. As x approaches +infinity, it goes up to infinity, and it's continuous everywhere. All right, thank you very much.